In this tutorial, we are going to solve some practice questions under radical functions, modulus functions, inequalities, and also more questions under the nature of the roots. So I've got my first question, which is saying solve for x in the following equations. Be sure to check answers and recognize any extraneous solutions. So what are extraneous solutions? Extraneous solutions, these are solutions which when you solve the equation, you definitely find the value of x. But if you plug in that value of x, it's not going to give you exactly as what you have. For example, if I find maybe x to be equal to 2, if I plug in 2 where there is x, I need to find 9. So if I don't find 9, then this x, this value of x is extraneous solution. Okay, in short, that solution is not part of the answer, or the value which you have found is not part of the solution. That's extraneous solution. So let's begin our discussion with the first question. So the first question is a radical function, which is the square root of x plus 6 is plus 2x is equal to 9. So how do you solve such kind of radical equation? So since we have got a square root this side, x plus 6 plus 2, or is plus 2x, is equal to 9. The only thing which we can do here is just to shift 2x to go to the right hand side. So we have x plus 6 is equal to 9 minus 2x. The reason why I'm doing this, I need to have the square root on its own to the left hand side. Okay, when I reach at this point, now I can square to get rid of the square root. So these 2 and the square root will cancel out, so I'll remain with x plus 6 is equal to, now here I'm going to say 9 times 9. This is the same as we have got 9 like this. You have 2 of these. Okay, so you start now. 9 times 9 is 81. 9 times negative 2x, that should be 18x. The negative 2x times 9, again negative 18x. The negative 2 times negative 2, which is going to give us positive 4x squared. Okay, now since I've got x squared and there is another figure which is just having x and a number without x, definitely that is a quadratic equation, meaning I can shift all these to the other side so that I remain with 0. So I'm going to have 0 is equal to 81 minus, these ones I can add them, which they are going to give me 36x, negative 18x minus 18x, then plus 4x squared minus x, I'm shifting now these to the other side, minus 6. Okay, so I have now 0 is equal to, so I have 81 minus 6. What are we going to have? Okay, so 81 minus 6, that is going to give me positive 75. Then 36, negative 36 minus that one, it should be it's going to give us what? Should be negative 37. Okay, so we'll have negative 37 x, then plus 4x squared. So allow me to get rid of this so that I rewrite that. So now this one I can rewrite it in form of this. It's the same as 4x squared minus 37x then plus 75 is equal to 0. So this is a quadratic equation. Now I'm trying to find the solutions. Okay, so now here what I'm going to do is I need to find the product. The product is 4 times 75. So 4 times 5 is 20, so I'll put 0. 4 times 7, it should be 28. 28 plus 2, 30. So 300, that's my product. My sum is negative 38. 37, sorry. So what will be my factors? Two numbers which when I do times, they should give me 300. When I do plus, they should give me negative 37. And those numbers should be negative 25 and negative 12. If I do negative 25 minus 12 is going to be 37. Negative 25 times negative 12 is 300, positive 300. That would mean to say I'm going to have 4x squared minus 12x minus 25x plus 75 is equal to 0. Now I can factor out 4 here. 4x, open brackets, x minus 4 into 12 is 3. Here I'm going to factor out negative 25. So I'm going to remain with x minus 25 into 75 is 3 is equal to 0. So since these are the same, we just get 1. So it will be now 4x minus 25, then again x minus 3 is equal to 0. So again, since I don't have space, I'm going to get rid of this. So now, meaning I've got 4x minus 25 is equal to 0. Shift 25 to the other side. 4x will be equal to 25. Divide both sides by 25, or 4, and x will be equal to 25 over 4. I'm done with the first x. I'll go to the next one, this one now. It will be x minus 3 is equal to 0. X is equal to 3. Now, these are my solutions. Okay? So my solutions are x is equal to 3 and x is equal to 25 over 4. Now, I'm not going to end there. I need to prove. Okay? As long as you are dealing with a radical function, radical equation, sorry, when you find the answers, you need to plug in the values. You see if that solution is what? Is not extraneous solution. So I'll start with 3. Let's plug in 3. We see if it's going to give us 9. So the square root of 3 plus 6, then plus 2, then here 3 is equal to 9. Okay, 3 here I'm going to get 9. The square root of 9 is 3. 2 times 3 is 6 is equal to 9. So 9 is equal to 9. So indeed x is equal to 3 is the solution for this radical function. As simple as that. Now I need to go ahead and also prove the second one. Okay, so we can clearly see that the second one is so we'll plug in the values here. So you have got 25 over 4 plus 6. Then here I have plus 2. 25 over 4 is equal to 9. Is this true? Let's see. 25 over this, what I have here, I've got 25 over 4 plus 6. It's the same as times 4 divided by 4. Because 4 divided by 4 is 1, so I will remain with 6 again. That would mean to say I've got 25 over 4 plus 24 over 4. So if I add those two, it's going to give me 49 over 4. Meaning in the square root, I've got 49 over 4 plus 2 into, this is going to give me 25 over 2, because 2 and 4, 2 is going to go, so I'll mean with 2 there, is equal to 9. The square root of 49 is 7. The square root of 4 is 2, plus 25 over 2 is equal to 9. Let's add this. So 7 plus 25, it should be what? Should be 32. So meaning I've got 32 divided by 2 is equal to 9. 32 divided by 2 is 16. So 16 cannot be equal to 9. Therefore, the extraneous solution here is this one. So you say, after proving now, how do you report your answer? You say the only solution for this equation is x is equal to 3. As simple as that. Okay? So that is very, very important. Now, you know, the way I've solved this question is as exactly as the way you are supposed to solve part 2 and part 3. So I want you guys to go ahead and solve part 2 and 3. Send the answers in the comment section. You can post it, or if you have my number, you can send the solutions in my inbox on WhatsApp. Okay? So this one, let me just give you a hint. What you are going to do in this case, you just shift this 5 to the other side, then square to get rid of the square root. Same applies to part 3. You shift this to the other side, then you square to get rid of what? The square root. So I want you to identify the extraneous solutions as well as the real solutions for these two, and send me the solutions. So now I'm going to solve this one because it's a bit different from the one I'm from solving. So this question is the root of 2x plus 3 minus the root of x minus 2 is equal to 2. When you have got 2 square root, get me right there. When you have got 2 square root, the only thing you can do is you have to get another square root to go to the other side. You can't work out with radical equation when you have got 2 square root to one side. Okay? So in this case, what I'm going to do, I'm going to shift this to go to the right hand side. So I'll have the square root of 2x plus 3 to be equal to 2 plus the root of x minus 2. Now at this point, I can square to get rid of the square root. So I'm going to do this. Even here, I'll do that. When I do that, I can clearly see that this 2 and that square root, they will cancel out. I'll remain with 2x plus 3. Then here now, I'm going to say 2 times 2 is 4. 2 times the square root of x minus 2 is going to be 2 the square root of x minus 2. Then again, the square root of x minus 2 times 2. I'll still get 2 times the square root of x minus 2. The square root of the square root of x minus 2 times the square root of x minus 2, meaning the square is going to be cancelled. Since there is positive here, it's not going to affect anything. But in a case where there is negative, you have to put them in brackets. So here, to make things simple and straightforward, I'm going to put them in the brackets like that. So in a case where we had a negative here, that negative, although would have not affected anything, because if you are multiplying negative by negative, would have gotten positive. So still we'll have that. Okay? So these two can be added. It's going to give me 4. So I'll still have 2x plus 3 to be equal to 4 plus 4 the root of x minus 2. Then plus x minus 2. Now, I can clearly see that 4 and 2, they can add up. Then I'll remain with 2x plus 3 to be equal to 4, and that one I'll get 2. Then 2, let me just write x here, then plus 4 the root of x minus 2. I've just gotten this and write it here. Okay, so now since I don't have space this side, I'm going to continue it from here. So from this point I can now shift this and that to the left hand side because it doesn't have the square root. So I'll say 2x plus 3, shift 2, it will be minus 2, shift x to be minus x, will be equal to 4 the root of x minus 2, like that. That would mean to say 2x minus x is just x, 3 minus 2 is 1. Then I have now 4 the root of x minus 2, like that. The next thing which we need to know is I'm going to, you can clearly see that I still have the square root. I need to get rid of that square root. At this point I can also square. Even here I'm going to square. So if I square this, it's going to be the same as the one I was telling you about. X minus or x plus 1, again x plus 1. So it's like you're expanding this now. So it is x times x, which is x squared. X times 1 is plus x. 1 times x is x. Then 1 times 1 is 1. Then here is 4 times 4 is 16. This one times, if I square it, meaning the square root has gone, like that. So this is going to be x squared. X plus x is 2x plus 1. So this will be 16x minus 16 times 2 is 32. Okay. What else? I can clearly see that I've got x squared. I've got again x and a number without x. That is definitely a quadratic equation. Shift everything here to the left hand side so that I minus 0 there. X squared plus 2x plus 1 minus 16x plus 32 is equal to 0. Let's get rid of this. Now I can clearly see here that x squared is alone. Even this one I can get rid of it so that I start from top here. X squared is alone. So now I'm remaining with 2x minus 16x. That is going to give me negative 14x. So I have got again 1 plus 32, which is giving me 33. Should be equal to 0. Perfect. Now let's get rid of this to create space. So we can clearly see that our product in this case, our product is 33. Our sum is negative 14. Okay? So if our sum is negative 14, what will be the factors? Let's see. What will be the factors? What if we say, I think it should be negative 11 and negative 3. So that when I say negative 11 minus 3 is negative 14, negative 11 times 3 is positive 33. That is perfect. Meaning that I have got x squared minus 11x minus 3x plus 33 is equal to 0. Let's factor out x. X open brackets. So x open brackets I'll have x open brackets. I'll remain with x minus 11. Here I can factor out 3. I'll remain with x, then since this is negative, divided by there, negative 11 is equal to 0. My solutions will be like that. x minus 11 is equal to 0. That is now x minus 3 is equal to 0, x minus 11 is equal to 0. Meaning if I shift 3 to the other side, I'll have x is equal to 3, another one will be x is equal to 11. Now, sometimes if you don't want to waste time, this is what you do. When you identify your factors and you realize that x squared has got the coefficient of positive 1, these are your solution. Okay, so you just say x minus 11 and x minus 3 is equal to 0, meaning x is equal to 11 and x is equal to 3, like that. Okay, after finding the answer, since it is a radical, we need to prove, is x is equal to 3 indeed the part of the solution, or it is an extraneous solution? Let's see. I have got the square root of 2 open brackets 3 plus 3 minus the square root of 3 minus 2. Is it going to be equal to 2? Let's see. So inside here I'll have 6 plus 3, 9. The square root of 9 is 3. Minus, here I'm going to have 3 minus 2, which is 1. The square root of 1 is 1. 3 minus 1 is 2. Indeed, x is equal to 3 is the solution for this equation. From there, we try again 11. The square root of 2 minus times 11 plus 3 minus the square root of x is 11 minus 2. Is it going to give us 2? Let's see. That is going to be 22. 22 plus 3 should be 25. The square root of 25 is 5 minus. That is going to be 9. The square root of 9 is 3 is equal to 2. 5 minus 3 is 2. So both 11 and 3, they are the solutions for this equation. As simple as that. Okay. So now that I've solved this one, like I've said, for second one and third one, I want you to send me the solutions. So let's now go ahead and try to solve the equations. Okay. So for the equations, we can clearly see that this equation, let me use different column. This equation, and that one, they are basically the same. So for this one, I'm going to solve the first one. I want you to go ahead and solve this one and this one. You are going to send me the solutions. So let's see. We have 5 divided by x plus 4 minus 5 or minus 4 divided by x is equal to 21 divided by 2 of 5x divided by 5x plus 20. The first thing is to make the left hand side to be the same as the right hand side, like it has to be just one fraction. So what I'm going to do is I have to find the common denominator, which is going to be x plus 4 times x. So that times that, I can clearly see that x plus 4 and x plus 4 will cancel out, and I'm going to remain with just x. X times 5 is 5x. Here I'll have 4, x and x will cancel, then I'll remain with x plus 4, like that. is equal to 21 divided by 5x plus 20, like that. Next, I can simplify the top part here. So it's going to be 5x minus 4x minus 4. 4 times 4 is 16. So that's what we're going to have. Okay. Then I divide this by x plus 4. Then I've got x should be equal to 21 5x plus 20. At this point, I can clearly see that 5x minus 4 is going to give me x. So I have now x minus 16, okay, divided by, if I want, I can also expand this. I'll say x times what is inside. So x times x is x squared. X times 4 is 4x. Should be equal to 21 divided by 5x plus 20. Like that. So I can get rid of this. At this point now, I can clearly see that I can cross multiply. So if I can cross multiply here, I'm going to say 21 times 2x squared is going to be 21x squared plus 21 times that, 21 times 4x. I'm multiplying this and 21. So 21 times, so I'll just say 4 times 1 is 4. Then I put x 4 times, that is going to give me 84. Should be equal to these ones, just put them in brackets for now, and we'll come and multiply them later. I don't have enough space there, so let me rewrite it. We are saying we are getting 21x squared plus 84x is equal to 5x plus 20 in the brackets, then x minus 16 in the brackets. Now the remaining part is just to expand this. So I'll keep on writing this as 21x squared plus 84x is equal to, so I'm going to say 5x times x is going to give me 5x squared. Then 5x times negative 16, what are we getting? That should be 5 times 6 is 24. Then 5 times 1 is 5 plus 2, it should be what? If we do the proper math there, we are saying 5 times x, we have gotten 5x squared. Then 16 times 5, isn't that supposed to be 80? 16 times 5, it should be 80, yeah. So it is 80, but negative, because 16 has got negative 80x. Then 20 times that one is plus 20x. Again 20 times 16, that should be negative, it's like you have got 160 times 2, so 0 32 3, so it's 320. That's what we have. Now at this point, we can clearly see that the only remaining part is just to shift. I'm going to shift everything here to the right, to the left hand side, so that I remain with 0 this side. So I'll say 21x squared. Since this is having squared, I'm going to say minus 5x squared, meaning that I'm done with that. I'm done with that guy. Plus 84x. I'm going to shift the 1, so now I can add these two, which is 81. It should be 60, negative 60, because you have negative 80 plus 20. They are both having x, so it's negative 60. Now that negative 60, if I shift it to the other side, it's going to be plus 60x. Okay, and then plus this one shifting to the other side is plus 320. Should be equal to 0, like that. So what is 21 minus 5? Okay, what is 21 minus 5? Is 16. So 16x squared. What of 84 plus 60? So if I do 80 plus 60 is 140, plus 4, 144. X plus 320 is equal to 0. Now this is the equation I have. I can reduce this equation. I think 16 can go into 144 and 320. So 16 into 16 is 1, so I'll say x squared. 16 into 144, it should be 9, because 9 times 16 is 144. So it's going to be 9x plus 16 into, just say 16 into 32 is 2, meaning 0 is 20, is equal to 0. I've reduced this now into this simple equation. So my equation now is x squared plus 9x plus 20 is equal to 0. Let's find the values of x. So the product is 20. The sum is positive 9. What will be the factors? The factors should be 4 and 5, both positive. Like I said, if the coefficient is positive 1 here, these are the solutions. You just say x plus 4 and x plus 5 is equal to 0. So that would mean to say x plus 4 is equal to 0, x plus 5 is equal to 0. So x will be equal to negative 4, x will be equal to negative 4, and x will be equal to negative 5. If you're having challenges on how to come up with that one, what you can do is just plug in the values. So plus 4x plus 5x plus 20 is equal to 0. Factor out x, you remain with x plus 4. Factor out 5, you remain with x plus 4 is equal to, it's the same thing. No one is going to penalize you. So you have that, which is exact as that point. Okay, now after finding the answers, plug in the values. Try to see if you're going to have extraneous solutions. Okay, so let's see. If x is negative 4, or another one is supposed to be negative 5, anyway, sorry, negative 5. Okay, now our equation, remember, I want you to pay attention here. We have got 5 over x plus 4. Okay, again here 4 over x. The moment I plug in here, I plug in where there is x, I put negative 4 plus 4 minus 4 over negative 4. Okay, get me right there. Is equal to 21 over 5 negative 4 then plus 20. one thing you are going to notice here is that here we are going to have 5 over 0. As long as on the denominator there is 0, that is undefined. Okay, so this part we're not going, it's not going to affect it. But here, even here, 21 over is going to be 20 minus negative 20 plus 20, which is going to be 21 over 0, which is undefined. Therefore, x is equal to negative 4 is an extraneous solution. It's not part of the solution. Okay, so this is not the solution for this equation. What of 5? Negative 5. We had negative 5. Let's not forget. What of negative 5? Let's see. If we plug in negative 5, here we're going to have negative 5 plus 4. Here negative 5. Here negative 5 times 5, then plus 20. So here we have 5 divided by neg 1. Then here it's same as just putting plus 4 over 5 is equal to, that will be 25. That will be negative 25 plus 20. So here is the same as negative 5, just negative 5. It's okay if you can write it like that way. Negative 5 plus 4 over 5 is equal to, this will be 21 divided by what? It will be 21 divided by, down here is going to be negative 5, like that. So let's see. On the left hand side, we need to come up with 21, which is the same as negative 21 over 5. So now I have got negative 5 plus 4 over 5 is equal to negative 21 over 5. Let's see. The left hand side, it is the same as rewriting it as 5, then I've got that divided by 5 plus 4 over 5. Why am I writing it like that way? Let me explain. I know that 5 divided by 5 is 1, so it will take me back to negative 5. If you don't understand that part, you can do it as like this. Then you put divided by 1, the denominator is 5. It's the same thing. So the common here, since it's going to be negative 25 plus 4, okay, divided by 5, even here 5 is equal to negative 21 over 5. The denominators are the same, we add the numerator. Negative 25 plus 4 is negative 21 over 5 is equal to negative 21 over 5. So the only solution for this equation is that x should be only equal to neg 5. As simple as that. So now I've solved this one. I want you to go ahead and solve this one and that one using the same principle which I've used for part 5. Now we are back for radical. We have now an interesting question, which is this one here. Let me solve for you. So we have the square root of x minus 6 square root of x is equal to 1. The only thing you can do here is just find a way on how you are going to get rid of the square root which is on the denominator. So you can do times the square root of x everywhere to get rid of the square root on the denominator. The square root of x times the square root of x is just x. The square root of x times 6 over the square root of x is going to give me 6, because these they'll cancel. I'll have 6 is equal to 1 times the square root of x is just the square root of x. When I reach at this point, I can now square to get rid of the square root. So it's like x minus 6 x minus 6. X times x is x squared. X times negative 6, negative 6x. The negative 6 times x is negative 6x. 6 times 6 positive 36 is equal to 2, and the square root will cancel. I'll remain with x. Meaning I now have x squared. These are going to give me negative 12x, then plus 36 is equal to x. Shift x to the other side. We'll have x squared. Okay. We'll have x squared minus 12x minus x plus 36 is equal to 0. That is a quadratic equation. Let's see. The product is 36. The sum, now I've not finished. So it will be negative 13x plus 36 is equal to 0. Okay. So the product is 36. The sum is negative 13. What are the factors? So the factors will be, if I do, should be negative 4 and negative 9. Yeah. Because that time that is 36 plus is negative 36. Negative 13, sorry. Meaning that if the coefficient is positive 1, those are my solutions. X minus 4, x minus 9 is equal to 0. So x minus 4 is equal to 0 and x minus 9 is equal to 0. Let's see. If I shift 4 to the other side, it will be positive 4. X will be equal to 4. Another one, x will be equal to 9. Done. Then you are going to see that these answers which I've just found, I need to prove. Okay. So I'll put, when x is equal to 4 minus 6 over the root of 4, let's see. Is it going to give us 1? So this will give me 2 minus, this is going to be 6 over 2. Is it going to give me 1? So 2 minus 2 into 6 is 3. Is it going to give me 1? Okay, we can clearly see that this is going to give me negative 1. Negative 1 is not equal to 1. Therefore, x is equal to 4 is an extraneous solution. It's not part of the solution. Let's try 9. The square root of, this is going to be 9 minus 6 over the square root of 9 is equal to 1. So this will be 3, then minus 6 over the square root of 3, the square root of 9 is 3 is equal to 1. Let's see. So we'll have 3 minus, that is going to give me 2 is equal to 1. Indeed, 3 minus 2 is 1. 1 is equal to 1. So the only solution in this case is just x is equal to 9. As simple as that. Okay, we now move to modulus function. Modulus equation, sorry. So the first one which I have is the modulus of x plus 6 is equal to the modulus of 3x plus 24. Like that. If you have got modulus both sides, you just put plus or minus to one side. So you choose where to put plus or minus. In this case, I'm going to put this side. So plus or minus, then I remove now the modulus. Even here, I'll just leave it the way it is. Don't put plus or minus both sides. Once you put plus or minus both sides, that is wrong. Okay. So The next thing here now is meaning I've got two things. I multiply first by positive, which is going to be x plus 6 is equal to 3x minus 24. If I multiply by negative, I'm going to say, or another one is going to be negative x minus 6 is equal to 3x minus 24. So I'll start with the one for positive. I'll start solving the top part here. So x plus 6 is equal to 3x minus 24. Shift 3 to the other side, 6 to the other side. So x minus 3x is going to be equal to negative 24 minus 6, like that. This is going to give me negative 2. Will be equal to, that should be 30. So it's going to give me negative 30. If I divide both sides by negative 2, x will be equal to 15. And now let's do for the negative. The one we multiplied by negative is this one. So negative x, I shift 3, is going to be like that. Negative 24, then plus 6. This is going to be negative 4x is equal to, that one should be negative 18. Okay, negative 18. So if I divide both sides by negative 4, even here by negative 4, my x will be equal to, negative and negative will cancel. So I'll say 2 into 18 is 9. 2 into 4 is so my answer will be 9 over 2. But let's see, do we have any extraneous solution? We start proving with 15. If I put 15 here, it will be 15 plus 6 in the modulus is equal to 3 times 15 minus 24. So that will be 21 now in the modulus. So 15, that will be 45. So 45, you do minus 24, definitely you get 21. So that's the part of, so x is equal to 15 is indeed the solution for this equation. Let's try 9 over 2. So 9 over 2 plus 16, it is the same as here I put 2 over 2. So it will be 12 plus 9. So 12 plus 9, it should be 21. So it's like you have 21 over 2. That is to the left hand side. Let's see that side. 3, then you have got 9 over 2 minus 24. So 3 and that one is 27 over 2 minus 24. So 24 is the same as you put 2 over 2. So which is going to be 48. So now you have 21, 24 times, okay, let me do this. Now you have got 27 divided by 2 minus, this is going to be 48 divided by 2. The denominators are the same, so you are going to add the numerator. So it's 27 minus 48, which is negative 21 over 2. But since it is in the modulus, it will still come out as positive. So we end up having 21 over 2 is equal to 21 over 2. So which is the solution, which is part of the solution. So x is equal to 9 over 2 is also part of the solution. So in this case, we don't have any extraneous solution. Let's do the last one. So the last question is the modulus of x plus 1 divided by x minus 1 is equal to 3. Here we know that where there is modulus we put plus or minus, but in this case even if I put plus or minus where there is 3, nothing is going to change. So I'm going to say I'm going to have x plus 1. I'll remove now the modulus. Then you need to put plus or minus here. What does it mean? It means that I have got x plus 1 minus what this is equal to 3, or x plus 1 divided by x minus 1 is equal to negative 3. So you solve now. I'll start with the 1 for negative. So I'll cross multiply in this case. Here there's 1. So if I cross multiply, I'll end up having x plus 1, the top part, is equal to 3 times x is 3x minus 3. So it will be x minus 3x is equal to negative 3 minus 1. This is going to give me 2x is equal to negative 4. I divide both sides by negative 2x. X will be equal to, if I divide that, it's going to give me 2. Let's do the one for the negative. If I cross multiply, I'll end up having this negative 3 plus 3, like that. So I'll have x, so that's supposed to be x. I'll have x plus now 3x is equal to 3 minus 1, like that. 4x is equal to 2. Divide both sides by 4, both sides by 4. X will be equal to 1 over 2. Now, I want you to help me try to plug in these values if at all you are going to get positive 3. So if we have any external solution, let me know. So that is it for question 1. So let's talk about inequalities. So the first question which I have here is saying 3x squared minus 4 is less than 4x. So the question is, find the values of x that satisfies the following inequality. So we have 3x squared minus 4 less than 4x. This is the same as the quadratic equation anyway. So I can say it's a quadratic inequality, where I can shift this 4x to go to the left hand side so that I remain with 0. Okay? So the rule of inequalities is to shift what you have to the other side. You need to have 0 actually to the other side. It can either be to the left side where you can have 0, or to the right side. It's okay. So in this case, since I've got 4x here, I'll shift it to go to the other side. Okay. So I can clearly see that in this case, I'm going to say 3x squared minus 4, then again minus 4x is less than 0. Rewriting this is the same as 3x squared minus 4x minus 4 less than 0. Reaching at this point, we can clearly see that we have got product as neg 12, because it's 3 times negative 4. The sum negative 4. What are the factors? So two numbers, I think it should be negative 6 and positive 2. Because if I do times these two, they'll give me negative 12 plus negative 4. Since the coefficient here is 3 and it's not positive 1, I'll rewrite this. Like that. Factor out 3x, x minus 2. Factor out 2, x minus 2, less than 0. 3x plus 2 and x minus 2, like that, is less than what? 0. Then I can clearly say that I'm going to have 3x plus 2 less than 0, shift 2 to the other side, 3x less than negative 2, divide it by 3x less than negative 2 over 3. Another one, since it is x minus 2 less than 0, so x will be less than 2. What does it mean? These are what we call critical points. So my critical points or my critical values are x is equal to negative 2 over 3 and x is equal to 2. When you do this, you need to come up with a table. Okay? What table are we talking about? You come up with a table. So this table, you are going to put your critical values. You start with the one which is negative 2 over 3 because it is less than 2. Then I'll put 2 here. Here I'm going to put a number which is greater than 2, which I'm going to say 3. Here I'll put 0, number which is in between negative and positive. Here I'm going to put negative just 1. Yeah, negative 1 is okay. So now what I have is remember we had at first, before we even reached anywhere, we had something like this, although I've just erased it, but it was x minus 2. We had this, we had 3x plus 2, like that. These are the things we are going to be putting here: x minus 2, 3x plus 2. Now the last box, you put both of them, x minus 2, 3x plus 2, like that. Done. Now the next thing which we're going to do is if I put positive 1 where there is x, am I going to get negative or positive? I'm going to get a negative because negative 1 minus 2 is negative. If I put negative here, am I going to get positive or negative? I'm going to get a positive. It's a negative. Negative 3 minus 4 is going to be negative. So now negative times negative, it will give me overall positive. If I put 0 here, 0 minus 2 is negative. If I put 0 here, 0 plus 2 is positive. Overall will be negative. If I put 3 there, it's going to be positive there, positive overall, positive. When I do this, I need to check my original equation here. Are we dealing with less than or greater than? We are dealing with less than. If we are dealing with less than, then the solution is going to be the one with the negative, since it is less than. When I'm dealing with greater than, I'm going to get the one for positive. Now I'm talking about the overall. The overall is the last line. So in this case, this is going to be my solution. That's not the solution. That's not the solution. Meaning that my solution is starting from negative 2 over 3 all the way to 2. Now, you check. This is just greater, less than, meaning it is not included. So you say the solution set is going to be from negative 2 over 3 comma 2, like that. So that's the values of x that satisfy the what? The inequality. Okay. You understand when we do the second one, I think so. That's the first part. Let's try to do the second one. So I want you to go ahead and solve part 3 because this part 1 is a bit similar to part 3. Allow me to go to part 2. So part 3 you can solve, you can find the answers and send the solutions in my inbox, or you can just put them on the comment section. I'll be able to check them out. So in the question 2 we have 2x minus 1 then divided by x plus 2 less than or equal to 1. So now here you always need to shift what you have here. You need to remain with 1, or you need to remain with 0. So I'll shift it to the other side. So I'm going to remain with 2x minus 1 divided by this, then minus 1 less than or equal to 0. Yes. So here I can put 1. The common denominator is x plus 2. If I divide, I'm going to end up having 2x minus 1 minus, because x plus 2 they are going to cancel out. Then here I'm going to have now minus 1 open brackets x plus 2 less than or equal to 0. The next thing is we'll have 2x minus 1 minus x and then minus 2. I'm just distributing this negative to everything what I have inside. So here I'll have x plus 2. So greater than or equal to 1, like that. Then greater than or equal to 0, not 1, because we don't have 1 here. The top part I can simplify it and say 2x, and that one I'll get x. Okay, I'm going to get x. What else can we see? Now here I'm going to have x, then here I'm going to have minus 3 divided by x plus 2 greater than or equal to 0. If we understood, I'll write it from here. So I'll write it from here. Okay. Let's first find the answers. When you reach at this point, you just get the numerator the way it is, x minus 3 greater than or equal to 0. Then the denominator just like the way it is, greater than or equal to 0. You solve for x. X will be greater than or equal to 3. The other one, x, will be greater than or equal to -2. I want you to observe the one we are saying x is greater than or equal to -2. That's not true. When we say greater than or equal to -2, meaning 2 is included. Okay? So if I include -2, if I include -2, it's going to be 0 on the denominator, which is not true. So this is going to change. Now it's going to be x is greater than -2. It can't be x is greater than or equal to -2, because if I include -2, it's going to give me undefined. This is the only these are the same things we were doing, and these are the same things we were doing under rational function. Okay, so I want you to understand the reason why I'm not going to say, even the time I'm going to be writing the solutions, as long as 2 is going to be part of the solution, it's not going to be included. If I include 2, it's going to be undefined on the denominator. Okay, it's going to be undefined. So we'll make sure to say the time we're going to be writing our solutions, it should be, it's not 2 is not going to be, -2 is not going to be part of the solution. That is very important for us to know. So let's continue. We see what we're going to have. So we're going to have now, I have my critical point. my critical values. You see, I'm writing critical values. Even you, when you're presenting this, you have to say critical values. X is equal to 3 and x is equal to -2. Come up with a table. So this table, I have got negative. I'll start with -2, then 3. A number which is after a number greater than 3 is 4. Again, a number in between I can put 0. A number here, -3. Perfect. So you realize that here, since we have this, you just get what you have here, x minus 3. Here, x minus or plus 2. Then here you just put the way it is. You rewrite it the way it is there. X minus 2 minus 3 divided by x plus 2. Like that. Now you start. If I put -3 where there is x here, so it will be -3 minus 3. -6 is negative. Here, negative. Overall, positive. If I put 0 here, it's going to give me negative. Here, positive. Overall, negative. If I put 4 there, positive. Here, positive. Overall, I'm going to get positive. Now, you go back and check the original sign which we are dealing with. I was dealing with greater than or equal to. Meaning that the negative part is not part of the solution. So that is my solution. That is my solution. This guy is not my solution. Now listen, guys. I mentioned to say this is greater than, meaning we are supposed to include it. So the solution set will be equal to, from negative infinity, since this part is starting from here, going to negative infinity. So starting from negative infinity, since I don't have enough space there, let me write it from here. I'm going to say the solution set will be equal to from negative infinity all the way to -2. Now, this is greater than or equal to. Once I put this where there is -2, that would mean to say we are including 2. We are saying 2 is part of the solution. So if -2 is part of the solution, then if I put here -2, it's going to give me 0. That is undefined. So I'm going to say not included. -2 should not be included. Union, but 3 can be included. So I'll say now 3 to positive infinity. So this is going to be my solution. So that side you need to be very much careful with the denominator, because you are trying to say that is not part of the solution. Okay? Yeah. Unless if it was just greater than. So now in that case, we are not including -2, because if we include -2, we are making our function to be undefined. Okay? So that's the reason why -2 should not be part of the solution. That's why it is open. After doing that, I believe you can do the same to solve. Okay, let me solve part 4 before I come to this part. So I'm going to solve this for you. Then again, I'll come ahead and solve this part, this one. Then you solve for me this one. You send me the solutions, but I'm going to solve that one for you. Meaning I've left 2. I've only left that and that one, which you are going to solve for me. So now let's go to part 4, which is so part 4. I'm going just to start from here. So since we have remember, like I said, the only thing here is just to shift this, what you have, to the left hand side, so that you remain with 0 here. So you have x divided by x minus 2 minus 1 over x plus 1. This one should be greater than 0. So what I'm going to have now, you are going to see that here the common denominator is x minus 2, then again x plus 1. Okay, on top here x minus 2 and x minus 2 will cancel out, so you remain with x open brackets x plus 1. Here you have negative 1, then x minus 2. You know what I'm doing here. Let's try to expand the top part. X times x is x squared. Okay, what else? Then x times that one will give me just x, then minus x plus 2. Okay, yes, plus 2. So what are we going to have now there? We have, yes, so we're going to have the down part here. I'm not going to simplify it, I'll just leave it the way it is, like that, greater than 0. So let's simplify the top part. So we'll have x squared, x and x will go, I'll just have plus 2 divided by x minus 2 x plus 1 greater than 0. You get the numerator the way it is, just get it. X squared minus 2 greater than 0, x squared greater than negative 2. You can't square something and get a negative, so definitely this one we leave it there. We say that is not part of our solution. You leave it, it's done. You can't square something and get a negative. So I'll now deal with the denominator. Denominator I have got x minus 2 x plus 1 should be greater than 0. What does it mean? X minus 2 greater than 0, x plus 1 greater than 0. So x greater than 2 and x greater than 1, neg 1. It's making sense now. I should come here and write my critical values. X is equal to neg 1 and x is equal to 2. Those are my critical values. Next, we need to understand that the moment you have got your critical values, you come up with a table now. But again, I want you to remember to say what we have here, we had something like this, because we are going to use that. We reached at the point where we had x squared plus 2, or it was, yes, plus 2 divided by x minus 2 x plus 2. So that was greater than 0, that part. So I want us to have that. Okay, so now here I'm going to put my solutions. Negative 1 will be here, 2 will be there. A number in between here I can get 0, a number here I can get 3, a number here I can get negative 2. So now the only things we are dealing with for now, okay, we are only dealing with two things. So we are dealing with x minus 2, because that is not part of our solution, so it's not going to be included. Then we are also dealing with x plus 1. Okay, what else? Now here you just write this the way it is, just copy it the way it is, like that one. So you say x squared plus 2 divided by x minus 2, then x plus 1, like that. Now if I put negative 2 here, am I going to get a negative or positive? It's going to be negative. Even here, negative. Negative times negative is positive. If I put 0 here, it's going to be negative. If I put 0 here, positive. Negative and positive, negative. If I put 3 there where there's x, it's going to be 3 minus that, positive. Even here, positive. Overall, it's going to be positive. So you go back to the function. Here we are dealing with greater than. As long as you're dealing with greater than, it can either be greater than or greater than or equal to. You get the positive part to be the solutions. So that's not the part of the solution. So you say the solution set is now this is starting from negative infinity. Sometimes you might be wondering why I'm starting from negative infinity. I'm starting from negative infinity because we can clearly see that from this point here it can go all the way. We don't know where it is ending. That's why it's negative infinity all the way to negative 1, not included union. Again, we jump this part. We are starting again from 2 all the way to positive infinity. So that is my solution. Okay? Now, after doing this, this is now the most important part, which I want you guys to at least understand. So like I've said, I'm going to solve this one, and that one. So I want you to go ahead and solve this one for me. You send me the solutions. So let's start with the first one, which is the modulus of x divided by x less than or equal to 3. This type of question, you can solve it using different methods. Okay? You can solve it using different methods. But here I'm going to show you just one so that it should not be complicated. But if you want to learn more about inequalities, there is a video which I posted on the website. Then you'll be able to see the other methods. Okay? So now here, since when you want to remove the modulus, you know that this is going to be plus or minus. Okay? So you realize that what you are going to have now, the moment you want to remove the modulus, this is going to change. So you're going to have two things. The one which is going to have negative and another one is going to have positive. So this can be written as negative 3 greater than or equal to. So I'm going to write let me just do it like this. It's like we have this. The one for the positive is going to be the way it is. Okay? I'm going to say x minus 4 divided by x is less than or equal to plus or minus. But the one having plus, get me right there, is going to change. Like I'm going to say x, it is the same as x minus 4 divided by x, then I'll say less than or equal to 3. Then here I'm going now to say negative 3, it should be less than or equal to this. I hope you are getting the logic there. So now I'm getting the sign I've just got a negative 3, then this sign just put it the way it is, like that. Okay, so now what is happening here, guys, is simple and straightforward. You know, even if you solve this the way it is, just solve the way it is, you are going to solve, you are going to have two answers. But I'm going to show you the simplest way on how you can tackle out this type of inequality. Okay, so if maybe you are already confused here, the best way you can do, just solve it the way it is, just solve it. You just do this. You say x minus 4 divided by x less than or equal to 3 plus or minus 3. So you're going to solve two things. Okay, the first one you're going to put minus, another one you're going to put plus. So you're going to say x minus 4 divided by x less than or equal to 3, or another one is going to be x minus 4 this. So the one for negative, now the sign has to change, so it's going to be greater than or equal to negative 3, like that. So solve now for x. I'll start with the first one. I'm going to say x minus 4 divided by x. So this one I will shift 3 to the other side, it will be minus 3 less than or equal to 0. I divide here by 1, then I'm going to have x. So here I'll have x into x is just x, or x into x is 1, sorry. 1 times what we have on the top part is just this, then minus 3x. So this should be less than 0. Okay, meaning that on top here I have got now x and that one negative 2x minus 4 divided by x less than or equal to 0. So you get what you have and find the answers. Okay, so now you have what are we going to have? We are going to have x negative 2x minus 4 less than or equal to 0. We solve for x negative 2x less than or equal to 4. Divide both sides by negative 2. If I divide both sides by negative 2, the sign will change. So I'll have x greater than or equal to now negative 2. Done for the first part. The bottom part you just get the way it is. You just say x will be less than or equal to 0, like that. Then you now solve the one for the negative, which is that part. So this part you also shift, it will be x minus 4 divided by x. Shift that to the other side, it will be plus 3 greater than or equal to 0. Here you put 1, so the denominator will be x. There x and x will go. I'll remain with x minus 4 then plus 3x greater than or equal to 0. So now I can clearly see that this part will give me 4x minus 4 divided by 4 greater than or equal to 0, meaning 4x minus 4 greater than or equal to 0 and x greater than or equal to 0. Okay, so now we can clearly see that we are going to have if I divide this one, I have got 4x minus 4 greater than or equal to 0. So 4x greater than or equal to 4 divided by 4, x will be greater than or equal to 1. How many solutions do we have? We have 4. This 0, again that one. But these ones, they are contradicting. X is less than or equal to 0. Another one is saying that x is less than or equal to greater than or equal to 0. So even when I'm going to put these on the table, I need to put all of them 4. Okay, my critical point values is x is equal to negative 2, 0 and 1. But 0, we have two zeros. Okay, we have two zeros, and we should not forget that we reached at a part where we had, allow me to put this one here. For us to find the first solutions, we had, for us to find these answers, remember, on top we had the negative 2x minus 4 divided by x, then we had the less than or equal to 0. Then the other one we had 4x minus 4 divided by x greater than or equal to 0. Let's not forget that. So my table now will be like this. I'm going to put 4 values, 4. Okay, since x is equal to 0 is the same, but the x has to appear here twice. Okay, so the first one which we have, I'm going to get just the top part the way it is, negative 2x minus 4. Then again I'm going to get x, which is just down here. Then again here I'll get 4x minus 4. But again there's also x here. Even if they're the same, I'm going to write it twice. Again I'm going to put x here. Okay, then here now it's just a matter of me putting negative 2x minus 4 divided by x. I put them in brackets, the last one. Then even here 4x minus 4 divided by x, like that. Done. Now here I'm going to put negative 2. Then here I'm going to put 0. Here I'm going to put 1. That's all. So one thing we should remember is that the number greater than 1 is 2. Here I can put 0.5. Here I can put neg 1. Here I can put neg 3. Let's see. If I put negative 3 there, what are we going to have? Are we going to get negative or positive? Okay. Are we going to get positive, negative, or positive? Let's see. So we are going to get negative. So I'll put it's going to be positive because it's going to be negative 3 times negative 2, which is positive. Okay. Then we go now to the second part. Do we expect to have negative or positive there? Let's see. So we are going to have negative. Then here it's going to be negative, there negative. So what will be the overall? The overall has to be negative. If I put negative 1 here, what are we going to have? So it's going to be negative 1 times that is going to be 2 minus 4, which is negative. If I put negative there, negative here, negative is going to give me still negative. Even here, still negative. So I've got 4 negative, it will give me plus. If I put 0.5 here, it will still give me what? Negative. If I put 0.5 positive, here is going to be negative, here positive. Okay, what will be the overall? The overall will be positive. If I put 2 here, if I put 2 here, it's going to be positive 4, which is going to be negative. It's going to be negative, yes. Then here positive, here positive, here positive. Overall negative. Perfect. You go back. Are we dealing with less than or greater than? It's less than or equal to. So you get the part giving you negative to be the solution. So that and that guy. These are not part of our solution. So I'll say the solution set will be equal to, now since it is greater than, we are saying it has to be included. Okay, so it's starting from negative infinity all the way to negative 2, included because it is greater than, less than or equal to, union, again starting from 1 to positive infinity. So this is going to be my solution. So that is it for this one. But again, let's go ahead and solve this part so that we understand better. Let's solve question 5, which is saying we have, what do we have? We have this, we are solving this one now. The modulus of x minus 2 divided by x plus 4 to be greater than or greater than 3. Some other people will tell you to say this is the same as negative 3 less than negative 3. They will tell you negative 3 greater than x minus 2 divided by x plus 4. Then here you just say greater than 3. It is the same as rewriting this as x minus 2 divided by x plus 4, like that. Then you say the first one is greater than 3, or x minus 2, the one for the negative now has to be less than. So in short, the one for the negative has to be the opposite of the sign which you have. That's why here for the negative we had to get greater than or equal to negative 3. So that is going to be plus 4, then you say now less than negative 3. It is the same thing. What I have here on top is the same as what I have there. Now you solve for the values of x, but still you use the same one to make things simple. So you say the first one which you have is x minus 2 you have this greater than 0. We put 1, so it will be x plus 4. So we put this again, we are going to remain with x minus 2, then minus 3, then x plus 4 greater than 0. Now at this point we can simplify. So on top we have x minus 2 minus 3x minus 12 is, we divide it by x plus 4 greater than 0, like that. Okay, so now here you are going to realize that if I do x minus this, is going to give me negative 2x. Then I have got 12, so I'm expecting to have neg 14. I divide this by x plus 4. Okay, we're expecting to have x minus 4. So, and then we can clearly see that this will be greater than 0. So you just get the top part alone, negative. I can even get rid of this so that I start from the top there. Greater than 0, 14. I've shifted 14 to the other side. If I divide here by negative 2, x will be now less than negative 7 over 2. Why negative 7 over 2? It's just negative 7. So it will be negative 7. Then the bottom part is going to be negative 4. It's like you have x minus 4 greater than 0. So x will be greater than negative 4. I have two critical points. But I'll need this. I should not get rid of this part because I need that part. So I can write that here. Negative 2x minus 14 divided by x plus 4 greater than 0. And the solutions here we have found that x is greater than negative 7 and x is greater than negative 4. Okay. Now I can get rid of this. Now I can get the other part. I also find the values of x. The other part is this one. X minus 2, x plus 4. So if I shift 3 to the other side, it's going to be plus since it was minus. So less than 0. Divided by 1. The common denominator is x plus 4. This one there, I'll still remain with x minus 2. Here, I'll remain with 3x plus 4 less than 0. So I'll have x minus 2 plus 3x plus 12 divided by x plus 4 less than 0. What's next? Here now I can clearly see that x and 3x is going to give me 4. So it will give me 4x plus negative 2 plus 12 is 10 divided by x plus 4 less than 0. Perfect. The next thing which I'm going to do, I can even get rid of this now because I no longer need that part. So it's going to be 4x plus 10 less than 0. Shift 10 to the other side. 4x less than negative 10. I divide by 4 here by 4. X will be less than 2 into 10 is negative 5. Here 2. I get again that other one is going to be the same thing. Less than 0. So x will be less than negative 4. Okay. So the critical points, I also need this. I should not get rid of that. I need that part. So 4x plus 10 divided by x plus 4 less than 0. What do we expect to have? So x, here we are saying that x is less than negative 5 over 2, and again x is less than negative 4. Let's see. Now I can come, my critical values I have, although those ones 4, negative 4, they are the same. So I'll say critical values. X is equal to negative 4, negative 7. I start with negative 7, it's okay. Negative 4 and negative 5 over 2. We're dealing with negative, 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 negative. After this, come up with a table. But remember, we have got 4 things. We have got 1, 2, 3, 4. Meaning that the table should have what? Is going to have 4. Like the one we had for the previous question. So have that. Okay, so 1 2 3 4 is okay. So we have negative 7 here. Next I'll put neg 4. What else? Negative 5 over 2. That would mean to say this part can go. Okay, so the first one which we have is x. I'll just copy the way it is here on top here, guys. Negative 2x minus 14. Then the down part is x plus 4. Again here, I'll copy the way it is. 4x plus 10. The down part is x plus 4. Then now, here I need just to write the way it is. 2x plus 14 divided by x plus 4. Then here I need just to rewrite again 4x plus 10 divided by x plus 4. Like that. Now we start. A number which is in between that, I can put negative 5. A number which is in between there, I can put neg 3. Here I can put 0. Here I can put neg 8. Let's see. If I put negative 8 where there is x here, it's going to be positive 16 minus 4, which is positive. Here it's going to give me negative. What else? If I put again there, it's going to be negative. Here negative. The overall is negative. If I put negative 5, it's going to be positive 10 minus 4, 14, which is negative. If I put there negative, here still I'll get negative. Even here negative. I have 4 negative. That would mean to say I'm dealing with what? Positive. Okay? I'm dealing with positive. If I put negative 3 here, it's going to give me plus 6, so it's negative. If I put negative 3 there, it's going to give me positive. Here, minus. Then here, positive. So I'll end up having again positive. 0 there, negative. 0 here, positive. Here, positive. And positive. The overall will be negative. Now you check which here the sign is greater than, so you are dealing with the positive. So this no, this no. So that guy and that guy is going to be my solution. Therefore my solution set will be, since it is just greater than, okay, since it is just greater than, so how are we going to write it? Since it is just greater than, so like I said, we need to be very much careful here. Okay, you need to be check the denominator before you even write your answers. Check the denominator. Okay, that will be very, very much important for you. So let's check the denominator first. What do we have? So we can clearly see that it's greater than 3. Okay, so um let's first just, I want us first to redo which part. I want us to redo this part. When we put -3, what are we going to have? Are we going to have positive or negative? Let's see. If I put -3 here, okay, if I put -3, it's going to be +6. This was 10. Okay, this was 10. Okay, so the mistake is here. Where is it? This is +10. I want to see something. Okay. So I can clearly see that this is 10. Okay. So if I put -3 there, okay, that's perfect now. If I put -3 there, what are we going to have? A minute. I want to see something, because we are saying if we put okay, since it is a modulus, let's see what we're going to have. So we're dealing with greater than. Okay. We're dealing with greater than. Okay, I've seen it now. So this part here, if I put negative, anyway, this is just okay, meaning that my solution is only that part and that part, meaning that my solution set will be from -7, not included, all the way to this guy. So we're starting from there, ending here, -5/2, not included. That is my solution. Okay, that is my solution set. So they're not included. That one we should know. So that is it for this one. But now I said I'm going to solve this one for you. I just want to explain something, not really solving, but I need just to explain something. The last one, I want you to solve the one for greater than 0, then you tell me the answer. So this one, since there is greater than negative, as long as outside there is negative, you are having a modulus outside there is negative, there is no need of you solving this one. So you just say this inequality has got no solution. You can't have modulus and come out with a negative outside, not possible. So it has got no solution. So go ahead and solve this one, and you come and tell me the answers. So you either send the solutions in my inbox if you have my number. So for those who doesn't have my number, you can send the solutions in the comment section. It's alright, I'm going to check them out and I'm going to respond. So that is it for inequalities. So let's try to solve question 3, which is saying find the values of p for which the equation px squared minus 3x plus 1 is equal to 0. The first one has got one real solution. So when we're talking about one real solution, meaning the discriminant is equal to 0. If it has got two real solutions, the discriminant is greater than 0. If it has got no real solutions, the discriminant is less than 0. What does it mean? You know, guys, when we are talking about this formula of the quadratic equation, plus or minus b, or is negative anyway, negative b plus or minus the square root of b squared minus 4ac divided by 2 So the only thing which determines whether we are going to have one Liu solution or two Liu solutions or no Liu solutions, it is the guy in the square root. So in the square root, we have b squared minus 4ac. Now, if here we are saying that if we have got b squared minus 4ac is equal to 0, then we are going to have one real solution. Okay, then we are also saying that if b squared minus 4ac is greater than 0, we expect to have two distinct real values. Okay, what if we have got b squared minus 4ac is less than 0? We are saying that we are going to have no real solutions. Let's see. If in the square root here we have got 0, since we're saying is equal to 0, if the discriminant is equal to 0, meaning that what I'm going to have here is not going to change. We are going to have one answer. That's the meaning here. And then if we are saying that two real values, if it is greater than 0, for sure, if here I've got 4, meaning that if b is maybe, let's say, negative 3 plus or minus, so the square root of 2 is going to give me 2, meaning that I have got negative 3 plus 2 and negative 3 minus 2. So these are going to be two different things. This is going to be neg 1, this is going to be neg 5. So I've got two different real solutions. If we are saying no real solutions, we are going to get imaginary. Let's say it is negative 4. So I'll expect to have the square root of negative 4 is 2i. So these are not real values. It is an imaginary number. Okay? So it is very, very important for us to know where these things are coming from. So here we are saying that no real solution. We're saying the first one is one real solution, meaning the discriminant is equal to 0. So we want to find the value of b. So b squared minus 4ac is equal to 0. Let's see. We can clearly see that our a is b, our b is negative 3, then our c is 1. Let's plug in the values. We find the value of b. So b is negative 3, but squared 4, my a is 1, my a is b. My a is b, then my c is 1. Negative 3 squared is 9. 4p is equal to 0. So I'll have negative 4p is equal to, if I shift 9 to the other side, negative 9. Divide both sides by 4, p will be equal to negative 4, sorry. We are dividing by negative 4. P will be equal to 4 over 9. So the first answer here now is 9 over 4. That will be the value of p if we have got one real solution. Perfect. What if we have got two real solutions? It has to be greater than z. So I'll have b squared minus 4ac greater than 0. So b is negative 3. We square it. 4a is b, then 1 greater than 0. So it will be 9 minus 4p greater than 0. Shift this to the other side. Negative 4p greater than negative 9. Divide both sides by neg 4. So p will be greater than. The moment you divide it by negative, the symbol will change. Or let me say the sign. Anyway. So p will be now less than 9 over 4. Meaning that the value of p will be from negative infinity all the way to 9 over 4. That will be the values of p. If no real solution, the last part, we are going to say less than. So it will be b squared minus 4ac less than 0. We plug in the values, neg 3 squared minus 4p 1 less than 0. 9 minus 4p less than 0. Shift this, 4p less than neg 9. You divide it by neg 4. Neg 4 p will be greater than 9 over 4. So the values of p should be from 9 over 4 to positive infinity. Done. Let's try to crack question 4. Let us try to crack question 4. So question 4, we have it's the same thing actually, greater than 0, meaning the discriminant. We want to find the values of k. So we'll say what is our a? Our a is 1, our b is k minus 1, our c is k squared. So since we've been told already that it's greater than 0, we'll just say b squared minus 4ac should be greater than 0. Then I'll start now plugging in the values. My b is k minus 1, but it is squared. For a value is 1, c is k squared greater than 0. The same. K squared, this is the same as k times k, k squared, k times 1, negative k, again negative k plus 1, minus 4k squared greater than 0. K and k, I'll get negative 2k plus 1 minus 4k squared greater than 0. Perfect. Now k squared minus 4k squared is going to give me negative 3. A quadratic now. The product is negative 3. The sum, negative 2. The factors will be negative 3 and positive 1. Yes. So we have negative 3 we'll have negative 3 k squared minus 3k plus k plus 1 is greater than 0. So I'll factor out negative 3k. I'll remain with k plus 1. Here I'll factor out 1, k plus 1 greater than 0. So I'm remaining with negative k plus 1, then k plus 1 greater than 0. Now we are trying to find the values. So we have got negative k plus 1 greater than 0 and k plus 1 greater than 0 as well. Now we have negative 3k, shift 1 to the other side, neg 1, divide both sides by negative 3, negative 3. K will be greater than. Now we have the sign is going to change because we have divided by negative. So k will be less than 1 over 3. This one now, k will be greater than neg 1. So we have two critical points. X is equal to neg 1 and x is equal to 1 over 3. Then we go back to our table. So I have neg 1, I have 1 over 3. So in between here I can put 0, here I can put neg 2, here I can put just 1. It's okay. So initially, before we found the answers, we had this, that guy and that guy. It's the one I'm going to put here. Negative 3k plus 1, k plus 1. So the overall will be negative 3k plus 1, then k plus 1, like that. So negative 2 here is going to be positive. Okay, it's going to be positive, so I'll put positive here. Here is going to be negative, overall negative. If I put 0 there, I'm expecting my answer to be positive. Here positive, overall positive. If I put 2 where there's negative 1, I'm expecting my answer to be what? To be positive. It's going to be negative. It's going to be negative because negative 3 times 1 is just negative 3 plus 1 negative 2. So here positive, overall negative. Now we check the original sign which we are dealing with here is greater than. You get the part giving you positive. This no, this no, this yes. So the values of k in this case, they are starting from -1 all the way to 1/3. Okay, so these are the values of x. So these are the ranges of the values of what? Okay, -1 not included all the way to 1/3.